welcome back to AWS On Air, coming to you live from the AWS Paris Summit. I'm Steve Roberts, developer advocate for .NET and PowerShell, joined by my co-host, as usual, AM.
I'm AM Grabelny, developer advocate for AWS Game Day.
And in this section, we're joined by Vincent to talk about Amazon DocumentDB Elastic Clusters. Before we do that,
thank you.
Please introduce yourselves and tell people, what do you do at AWS?
Thank you for hosting me. I'm Vincent Gronkowski, so I'm a principal solution architect, specialist in analytics. And today I will talk and discuss with you about DocumentDB Elastic Clusters, because this is a huge feature and a huge improvement we announced last reInvent.
Cool. So before we get into Elastic Clusters part of it, can we have a brief summary of what is DocumentDB? Because we obviously got a lot of viewers, probably some of them are not familiar with that particular service.
Sure. So DocumentDB is a database service that is scalable, highly durable, and fully managed. It's a good fit for mission-critical workloads that are based on the MongoDB API. And before we switch on Elastic Cluster, I just would like to remind the design of the existing deployment model, because this is very important to understand the challenges and what Elastic Cluster can solve. Okay.
Yes.
So the current deployment model that we had, the initial one, was the instance-based cluster. And it was scalable already because you have this decoupling of storage and compute. You have this auto-scaling on the storage up to 128 terabytes of data. And you could also scale on the compute layer, adding some read replica to a scalable read, obviously, up to 15 read replica in your cluster, but no writes. Okay, so you have a single instance for the write. That was one of the challenge on the scalability. The service is highly durable. Okay, you have this multi-AZ design. The data layer, the storage layer, replicates your data across multiple AZ. In terms of compute, you can also add nodes across AZ, and you have an automatic failover. So the service is highly resilient, highly durable. And finally, it's fully managed. You know, AWS takes care of operations for customers. They can benefit, for example, from automated backup with an incremental mode. They have this automatic failover. For example, if the writer, the primary node is failing, a read replica can take over and continue the service, the database. You have also automatic patching, security best practices by default. So yeah, the classic fully managed experience.
So can you talk a little bit more about that scaling that you mentioned? Right? How do customers work with that?
Yeah. So this instance-based cluster, it was already a good fit for the majority of the workload. But some of our customers, the ones with huge scalability, huge growth in the business, they told us that sometimes it was difficult to scale beyond these limits of a single writer in the cluster. Okay, they wanted to provide more write capabilities and more storage also. And they wanted something that is simple because the existing workarounds were a little bit complex. I will come back on that later. So yeah, they asked us for a solution, and they asked AWS to manage this for them. And that's why we launched this Elastic Cluster feature. With this one, they can start small, and they don't really need to worry anymore about scaling because the database layer will take care of this for them.
That's really helpful. That sounds nice.
Yeah.
I mean, yeah, traditionally when you're working with DocumentDB, what are the kind of limitation factors that you in your day-to-day work with your customers, for example, what are you addressing there? It sounds probably not so much the compute side. It's more the storage side that you're looking at as the limitation factor. But that might be too reductive. So what do you think? What are some of the challenges that you see across your account?
So first, the storage, definitely. With the instance-based cluster, you can scale up to 128 terabytes.
Right.
It can fit majority of a workload, but yeah, sometimes you don't expect a growth in your business application. Yeah, you are surprised like that, and you need to.
It's usually a good. It means good things are happening,
exactly.
right, for your business.
Usually.
So yeah, there was some workaround, definitely, and we'll come back on that later. But that was the first challenge, and the second one was also on the write capabilities. On the compute layer, we had up to 15 read replica, and the read replica could be different size. So you could potentially have lots of read operations, but not for the write. And for the write, you had this single instance cluster limitation. That was clearly a challenge for huge write-heavy workloads in general. Yeah.
I mean, that sounds pretty typical of most databases too, right? Like very easy to address some of the higher read loads. You know, read replicas, you could drop a cache in front of it, all kinds of things. But
Exactly.
write, it's always tough, right?
Yeah.
No matter what you do.
Yeah, and you have this consistency issue also.
Oh,
If you start distributing things on multiple nodes, that can become very crazy.
Yeah. Before we move on, Vincent, I know this is probably a contentious question, so feel free to disregard it. But are there any types of workloads that you can help our audience understand that are good use cases for DocumentDB, right? So, you know, it's very challenging, I think, for a lot of people, especially people new to AWS, to pick a database, right? I'm definitely not asking you to say unequivocally, this is how you pick a database. But are there any indicators when you're working with certain workloads that DocumentDB is the right choice for you?
Yeah, definitely. So DocumentDB is a JSON native document database service. Right. So typically,
if you JSON documents,
if you want to start JSON documents, you want a schema-less database. You have lots of schema changes in your incoming data. Yeah, that's a very good fit. Okay, and when you want to have the enterprise capabilities on top of that, this is where DocumentDB is a very good fit because you have scalability, durability, resiliency, all the enterprise features are provided and automated in the service.
Right, yeah.
And now, with Elastic Cluster, in addition, on top of that, you have a huge scalability on the storage and the write operation, in addition to the existing features. So you can scale up to 2 petabytes of storage.
Oh, wow.
Yeah, instead of 128 terabytes. That's a huge improvement.
That's a big difference.
Exactly.
Wow. Okay, yeah.
And same thing for the writes. So you had already the capability to scale the read on millions of reads per second. Now you can also scale on millions of writes per second.
Wow, that's incredible.
Yeah.
I mean, that is traditionally like when what, probably a decade or more ago, when NoSQL started to emerge and started to be a viable solution. You were often trading, you know, the flexibility of NoSQL for the lack of kind of enterprise grade features that you would find in more of a traditional SQL database, right? But it sounds like those days are over, Vincent.
Yeah, exactly.
That's amazing.
Exactly.
I love it.
So earlier on, you were talking a little bit about durability. How does that work now that we've got this big increase in scale? You already mentioned it's multi-AZ, etc. But how does that kind of play into this?
Yeah. So it's durable on the storage. So you have this decoupling of storage and compute, okay? We have a fleet of instances that manage the storage for the customers, and customers only pick the right instance size for compute. And on the storage, we have this high durability with replicating the data, okay? So when you store one document, for example, in your document database, it's replicated 6 times, okay? 6 times and in 3 AZ minimum.
Okay.
That's pretty durable.
Yeah, exactly.
Yeah.
So we ensure that the write is fast, quickly replicated, and also replicated across AZ in case of big failures. You have this automatic failover because you can also split the compute into multiple AZ. So you are able to, you already have a copy of the data in the other AZ. You don't need to replicate it or to move it. You can just have this automatic failover on top of the other AZ copy.
That's incredible.
Yeah.
So this really does take away, you know, as a solution architect, I was once upon a time a solution architect as well, I'm a developer advocate now, but you know, we often deal in trade-offs, right? Like that's our bread and butter when we talk to customers. This really reduces some of the trade-offs that you have when moving to DocumentDB, right? Like, so when you're evaluating which database, this sounds incredible, actually. A little amazing.
It's a game changer, honestly, for developer and for also operations. Okay?
Right.
Because that's the 2 most critical challenges that they have. Okay. Scaling the storage, scaling the throughput on write, and you had some workaround, but it's clearly an overhead. Okay, overhead on 2 points: on developers because they need to typically partition the data across multiple clusters. So the idea was, okay, I will split my data in multiple databases. Each database will have its own cluster, so I can isolate the write and the read and have some scalability. But the logic of partitioning is in the application layer. Okay, so that means the developer need to implement algorithm to route data, retrieve the data.
Developers love writing code to work with partitions, don't they?
It's not business code. Okay, they should really focus on what brings value to their business.
Yes.
And not on infrastructure management.
Agreed.
Yeah,
Agreed.
that's the first overhead. The second overhead is on the operation also, because if you have multiple clusters, that means you need to maintain that. And for example, you have an operation to run on the database.
Right.
Now you have multiple clusters to orchestrate, and you have some challenges like partial update or rollbacks, and that's crazily complex because you have some kind of distributed transaction on your operation.
And also you introduce time, right? Which is never fun to deal with when working in IT.
And just another example is monitoring. You want to monitor your database performance. If you have multiple clusters, you need to monitor all the clusters. You need to aggregate the metrics. You need to check the capacity of each of them. That's very complex, and we really simplify with Elastic Cluster. Yeah.
I love that. Now, Vincent, you teased us earlier before we went live that you do have a demo of this.
Yeah,
right?
exactly.
You think it's about time?
I think so.
Okay.
It's always time for a demo.
Maybe just before we go on the demo, I can explain a little bit what is Elastic Cluster in some details, with some technical details.
Love that.
Sure.
Yeah, that's great.
Cool. So what we used to scale this right, if we take the baseline as the instance-based cluster, consider it as a building block with storage, one writer, one or more readers. Okay. What we use in Elastic Cluster is sharding. So you can horizontally scale by adding more building blocks. Okay.
Okay.
And that means behind the scene you can use the sharding API of MongoDB to create sharded collection.
Oh, nice.
And we manage the distribution of the data for you. Okay, so you just define a shard key in your collection. We take the field, and based on an algorithm, we will partition the data on the right shard.
Oh, wow.
And the beauty of this design is that each shard has its own writer, because it's an instance-based cluster or similar.
Oh, wow.
Yeah, that means you can just scale out to 32 shards.
Yes.
And just increase your write throughput, adding new shards.
So all I have to do is define the shard key.
Exactly.
You take care of the rest.
And you create a sharded collection instead of a non-sharded collection.
Okay.
Yeah, that's it. So minimal change also on the code, on the application code.
Right. And so you would as you were planning, right, your retrieval and your writes, you would just plan out basically, if you had the information, on which collections would be heavier writes, you would just build a shard for each of those. Is that?
Yeah. So you're right. You need to define the right shard key. That's one of a trade-off, I would say, because you don't want data skew, you don't want unbalanced shard. Okay, so you need a key that has high cardinality in general.
Okay.
And good distribution of data. Yeah, I can show that in the demo.
Oh,
yeah.
wonderful. Okay. Very cool.
Cool.
Yeah. Let's make sure.
Let's see it.
We get your screen pulled up. I believe we've got it.
Okay. So here I'm in the console. I will just show you how to create an Elastic cluster. And you see that there is the traditional mode, which is the instance-based cluster. And now you can create the Elastic cluster, just give a name, and then you precise the shard count and shard capacity. So this is very simple.
Okay.
Shard count is the number of building blocks you want in your cluster, and shard capacity is the size of each building block, because you can also vertically scale each shard. Okay.
So I can change the shard count later?
Yeah, sure. I will show you that just later. Okay. And obviously, you can place your instance in a VPC. So also, what is important to notice is you don't put all the shards in your VPC. You just put the endpoint in multiple subnets, and that means all the application in each subnet can access the database. Okay.
Oh, okay.
And we access the router. Router will automatically load balance and partition the data for you.
Nice.
That's cool. Yeah. So you select the subnet. Here I don't want. I will select the 6 of them. Security group. Just precise a password, username that I will use to connect to my cluster later. Also, something to notice is the encryption. With Elastic Cluster, you need to encrypt your data. You can use the default key, or you can bring your own KMS key, of course. And that's it. I just create the cluster. It's available a few minutes after. Okay.
Wow.
So now I will show you how you can scale that. And this is one of the most important features. Here I have 2 shards with 2 vCPU.
Yep.
I just decide that I need more. And I just change the shard count to 4, for example. Doubling is easier because for data movement, it will be faster. And then I just also change the number of vCPU per shard to 4. And that's it.
That's it?
That's it.
Wow. I was hoping for more.
I wasn't. I was hoping for exactly that. That was amazing.
So you wait a few minutes. The service will reorganize the data, create the instances, rebalance the shards, and that's it. And then you can start using the database.
See,
So
this is the type of operations that I, as a developer, am looking for, right?
Yeah.
Like, this is it. I don't want to get deeper than this, personally. So this is really, you called it a game changer. I believe you now.
let's see now how you can use it. Okay, I will use the Mongo shell to connect to the database, and I will use the sharding API to create my sharded collection. So this is the endpoint, the router in front of all my shards. Okay, I just connect to that. And for example, here I'm creating a sharded collection with some employees information. And what is important is to note the shard key, which is the employee ID. And I'm using a hashing algorithm to partition the data on that. So now I can ingest some data, some JSON documents, employees with some IDs. And if you note the employee ID, I put a huge load on the number 1 because I want to create unbalanced partitions and shards.
Oh, I see. Okay.
All right.
And we will see how you can monitor that because we also provide the tools to help you on that.
Interesting.
So just an aggregation to count the number of employees. You can see we have 13 employee ID 1, and the others has only 1. Okay, so we should have clearly unbalanced.
Yeah.
So yeah, we also provide monitoring because now sharding is a little bit of a challenge. You need to pick the right shard key. You need to monitor each shard. And we help you also on that. If you go on the console, you can monitor the entire cluster. You can see the throughput of write, read, but at the cluster level. So it provides you a good first view for the developer on the database service. Okay. So for example, we can see the documents returned, updated, inserted. But I want to know more on this sharded collection. I want to have the shard view because it can be critical.
Right. Yeah, I mean, this is what we were talking about earlier. If you don't already have this information, you're collecting it right here. And now you're learning which IDs in your collection are hot partitions.
Exactly.
This is cool.
So for that, I can go to CloudWatch. And you see that if I look for DocDB metrics, you have the cluster scope, but you have the one shard for the shard.
ID.
Yeah, shard ID. Yeah. So we will first need to filter on the cluster ID. And I will go back on the console just to collect the cluster ID. And we will see that we will have multiple metrics, 1 per shard. That's really interesting. So typical metrics that you can monitor for data skew and hot partitions or hot shard is the documents inserted, for example. So I'm looking for this specific metric. And that's it. You see, you have 2 metrics because you have 2 shards. Remember, I created the cluster with 2 shards.
2, yeah.
So I can select them, and I can just grab them, and you will see that it's unbalanced.
I would say why that one went orange. That's just a different cluster label. Okay.
Yes.
It's 2 different shards.
Yeah,
so you
2
see,
different shards.
and you see the peaks, okay, on the blue one.
Yeah,
this is clearly unbalanced.
Yeah. Cool.
Yeah. So we also provide the tools for developers to select the right shard key to monitor their application. That's a really cool feature also.
That's cool.
In this case, how would you solve that? What would be the shard key that would alleviate
So
this?
my example is not really representative. It's very small.
Sure,
okay, and I voluntarily created a bias in the data.
You did.
Okay.
You did.
But yeah, typically you pick a high cardinality key.
Something very unique.
Yeah, exactly.
Okay.
And if you have a very high cardinality, you don't really care about data skew because it will balance, it will round robin or hash the value. So it will be distributed. If you have lower cardinality, you need to be careful about data distribution across the values.
Fair enough.
Yeah.
Fair enough.
Fair enough, yeah.
Well, great. Vincent, this was incredible. Like I said, I didn't doubt you ever, I promise. But you proved it, too. You proved this is a game changer. This is incredible. Yeah, absolutely. We've got about a minute left. Anything else you want to share with our audience? Anything that they should go check out additionally beyond this? Or
testing it. Yeah, you have seen it's super simple to test.
Right.
Yep.
You can go through console. We have API, CloudFormation, Terraform, CDK, whatever you need.
Yes.
You can just test it. And I really encourage to test the scaling because it's really on the operation that is important.
Yeah.
Yeah.
I love it. Well, thank you for joining us so much.
Yeah.
I really appreciate you coming on the show.
Thank you for hosting me.
Yeah, of course, of course. For all of you watching, we will be back with more from the AWS Summit here in Paris. We're live. We're monitoring chat. If you've got questions, drop them in. And we look forward to talking to you throughout the entire day. We'll see you in just a few more seconds. Stay tuned.